construction document sets. So there is going to be a lot of repeat and a lot of overlapping, and that's just because these are some really important concepts for us to hit on. There are things that we're going to look at throughout the rest of this entire semester, so I'd like to make sure that we are understanding it and getting it, so we're going to look at it in a bit of detail. The first thing I just want to touch on before we jump into these standards and document sets are what they are printed on. Whether we are printing physical hard copies or printing to a PDF file, like a digital file, we are still going to be setting things up in a paper space on the computer, or in this case, we're doing everything by hand, so just using physical copies of paper. And we need to just understand the size of the paper we have in relation to the size of the scale of our drawing or whatever we are creating. Now, there's two different families of paper types. We have kind of just our regular standard paper types. So right here would be just a standard 8.5 by 11 sheet of printer paper. And then what we'll use for our first hand-drawn project is a sheet of tabloid paper, which is 11 by 17. And then they can just kind of be sorted out exponentially from there. So you can just, two pieces of letter, make a ledger, or make a tabloid rather, excuse me, and then two tabloids can then make a size A2 sheet, and so on and so on. And that's going to be just one family of paper type you can find. What we deal with when we're in AutoCAD and with Revit is we deal with architectural sizes. So the largest size architectural paper you can have is a size Arc E, which is 48 inches by 36 inches, or 4 feet by 3 feet. And if you're thinking, wow, that's a huge sheet of paper, you are not wrong. It is a very large sheet of paper, but we would use that for really major, very, very large drawings of very large buildings. So if I'm making a big skyscraper where I'm going to have a lot of stories, a lot of pieces of information I need to put on there, then I would consider an architecture E. What we're going to look at in the documents that I have just to go over today are printed on what's called an Arc D, which is 36 by 24. So it's half that size, and it's still a pretty large sheet of paper, and that's a very standard size for lots of different projects. So that's one that we'll see commonly. And then of course you could split that D into half, and then you'd have an Arc C, and you can split that into half into a B, and then you can even split that in half into an A. So again, they're kind of have a golden ratio to them of how they get split. A lot of firms will just have D on hand. So particularly like in my lab, we just have architecture D paper because we actually buy it in rolls for the plotter, which is just a fancy name for a big printer. And that way I could print onto architecture D, and I also technically can print onto a size C sheet from that roll, since my roll itself has a width of 24. And after that, I can just kind of cut the B or A to size if I needed something like that. So that's just something to kind of keep in mind, is that when we're setting our drawings up to scale, we need to take into consideration A, how much detail we need in our drawing, and B, what size paper we're dealing with for those drawings. Now, in our drawings, we'll see a variety of different types of lines, and then they'll also have different line weights, and that's just kind of how thick the lines are. And those lines are going to symbolize different things. And I don't know if you can hear it in the background, but one of my cats is playing with a squeaky toy, so I apologize if there's an annoying squeaking going on. So the most common style we'll see is just a visible line or an object line, which is just a continuous straight line with no gaps or breaks in it. And this is just to show visible edges of things like our interior and our exterior of our walls and countertops and furniture layouts, where our doors are, the swing of the door. All of that's going to be done with a continuous line. But one of the big differences we'll see in continuous lines is how thick they are. So they'll have different line weights to kind of represent the hierarchy of the lines. So our walls will typically have that thickest, boldest line in the drawings, and then kind of the next step down would be our doors and our windows, and then the next step down from that would be countertops, and then the next step down from that would be things like furniture plan layouts or hatching for different materials or different like floor styles, and we'll go over hatching in this lecture as well. Um, but you're going to see a just continuous regular line quite a bit in drawings, and the weight is really what's important with the continuous line. Another type of line we'll see is a dashed line, and it's kind of tied between a dashed and a hidden, and you can see the difference is that with a dashed line, the lines are a little bit longer, versus with a hidden, they're much shorter. Dash lines are used to show features that are underneath our current view. So if you remember from the orthographics lecture, I described a floor plan as if we're kind of cutting our building open horizontally and then looking down into it. And so if I'm looking at my floor plan from above, I can't see features that are in like the foundation, such as footings and things like that. So those would be represented with a dashed line, which again shows features that are below our current view, but it's just kind of a little bit of a longer series of, for lack of a better word, dashes. Now, a hidden line is a series of short dashes, and again, if we remember from our orthographics lecture, hidden lines are showing features that cannot be seen in our current view but still exist. But in architectural drawings, they're typically used to show things that are above our current line of sight. So again, if we're situated at 4 feet above the top of the floor, we'll be able to see quite a lot of features of the house, but we may not see, upper cabinetry in the kitchen, or if it's a house that has stairs to it, we'll see some parts of the stairs, but not all of it. So then maybe part of the staircase will be drawn with hidden lines, though sometimes the entire staircase is drawn in on drawings. And that kind of the difference of whether the stairs are hidden versus they're just solid in the plan is more of a stylistic choice. But the hidden lines, again, are used to show things above our view plane. Center lines are a series of long, short, long, short, long, short lines, and they are used to help grid out our drawing as well as show symmetry between. So if I have a very large plan or even just an average size plan, I might use center lines to help grid out my plan into different sections, so that way I can deal with different sectors of the building rather than the entirety as a whole. Or I can use a center line to show that two features are aligned with each other. So if I had two windows on opposite sides of the building that shared the same measurement, I could use a center line to help show that those two are at the same place, aligned with each other, or I could use it to help find the middle of a post or beam within the building. So center lines are used to help show symmetry within the building as well as to grid out a space. And then phantom lines are a series of long, short, short, long, short, short, and they're typically done very bold in drawings. And these are used to help show boundaries of our space, particularly in a site plan or just kind of the land layout of the piece of property that you've bought. So they help show our boundaries. And then you can also see them be used in plans for a cutting plane for a section to show where a building is being cut open in a particular set of plans. So to look at some of these in action, I've got a couple of set of plans, and you can find these up on As You Learn in the Architectural Symbols and Standards folder There are copies to these PDFs, so you have these as well if you want to look them over a little bit. So this is a set of plans for a lake house. There's 7 sheets here in total for this lake house. And we can see here in this site plan a lot of those different line types being used already. Particularly here is our phantom line to show just the edges of our property boundary. So it's that long, short, short, long, short, short. And then also here in this site plan for the piece of property, we're seeing a lot of different line weights. So we're seeing a really bold line go for the property line. And then there's also a really bold line here that's still a continuous line. That's just showing like the outside of the house. So just the general boundaries of the house footprint. And then there are some continuous lines that aren't as heavy of a line weight, and these are just representing the different slopes of the roof when we're looking above. Some, again, continuous lines that aren't as bold to show the different deck heights. Some less bold lines to show things like where the driveway is. And so we've got a couple of different line weights in there. We've got some hidden lines, which in this case are helping describe topography, but I don't want to get into that too much because we do have a specific day dedicated to topography and things like that. So we've got quite a few different line weights happening here alone just in the site plan. And then we've also got some different line weights and line types happening here. So this is the foundation plan for our drawing. We've got continuous lines for just the foundation walls. And walls, no matter what, are always shown with an exterior and an interior because we need to show the thickness of the wall itself. So we always have an outside and an inside. And then we have these dashed lines going around both the outside and inside. And that's then representing the footing that's sitting underneath that foundation wall because it's below our current view if we're looking at the foundation plan. And we also have some dashed lines to represent footing for these piers that are located to help hold up part of the foundation or part of the loft that's in this building. And then we've got center lines too. So I've got these long, short, and these are just referring to help show the center of these posts. So that way we can just kind of help align where they are in our drawings. And also, so since I have a measurement here that says, could say 13 or 15, it says 13. I'm a little further away from my screen so I can see too well. But so it's telling me here that it's 13 feet. And that way I wouldn't have to have, a measurement on this side telling me where that is. So this way we can borrow some of those measurements out to the centers. So again, that we've got that for symmetry. And then if we scroll into like the floor plans for the upper level and lower level, and let me zoom out so we can see kind of more of the sheet in its entirety. Again, we've got those bold lines that are continuous for the walls. We've got center lines for some of the posts. We've got different line weights happening then for things like our doors and our windows. They're still done with continuous lines, but the line weight's much less. And then we've got some hidden lines to help show features that are above our view. So this hidden line is referring to the floor of the loft that's above our specific view. In this case, we've got some hidden lines, and I'll zoom in on it a little bit. We've got a little walk-in closet here, and we've got some hidden lines to just show that there are some features in this closet. So some just rod work that is just not available in our view. Here in the kitchen, we have hidden lines to show that there's cabinetry, upper cabinets that are just above our particular view, and a center line to help signify where the ridge for the slope of our roof is. So just some things that can't be seen in our view, but we are referencing the different line types to help understand a little bit of it. And then again, here would be those elevations. So this is kind of thinking about orthographics again of looking, but this time we're looking at a building from its 4 different sides. And here with our orthographics, we have a few different line types representing things like our footing and our foundation wall that is in that dirt out of our view. Some hidden lines to show where we have kind of the heights of different floors happening in our building. But a lot of that line work is just done with continuous lines, and it's just done with different line weights. So we have this really heavy continuous line for our ground line of our exterior, and then we have some bolder lines for just the overall outside of the building, and then some thinner lines for things like our hatching, our different patterns on our siding and our windows and things like that. Now, in your project, you're not going to do an exterior elevation like these. You're going to do more of an interior elevation, and we'll look at some of those too. But this is just kind of to get acquainted with how these plans look and how to read them and things like that. And here is another set of plans. This is just for a 2-unit kind of condo, but we still have a lot of those same line types at play, where we have lots of continuous line work happening in there. Boldest line would be for the walls, for the outside and inside of the walls. And then we have some thinner line work for windows and doors. And then things like our cabinetry and our kitchen work, and maybe then any other built-ins are kind of done with a little lighter line. Now, some of the lines here are also a little different or contrary to what I mentioned just in my presentation. So for example, here is a center line being used to describe cabinets that are above our current line of view. And there's still like a center line here for this rod that's in this closet. So everything is not necessarily set in stone, the absolute do it this way. I'm going to tell you my preferences. I'm going to tell you what most of the plans I have looked at and what people prefer them to be. But ultimately, as long as you are following good guidelines, and especially referring to that AIA student handbook that is in the reading section on As You Learn, you will be in an okay position. But there is some wiggle room for a couple of the different standards and symbols that we're going to look at today and tomorrow. And I know, unfortunately, you don't really want to hear, oh, well, sometimes you can do it this way, sometimes you can't. So I'm going to tell you the way I would prefer to do things, but ultimately you can, in some instances, you can stray from that, but I wouldn't recommend straying too much all the time. So like for me, I would prefer these to be hidden lines and not center, but I certainly can't stop the person who made these plans from making them that way. And again, here we still have, so these would be elevations of the building. We have a heavy bold line for the ground line or the finished grade. Then a still pretty bold, but not as bold line for just the outside perimeter of the building. And then some lighter line work for things like doors and windows and the material hatchings that go on the building itself. We've got dashed lines to represent things like our foundation walls and our footing that are below the ground and outside of our particular view. And we can just see a couple of those different line types in action in these sets of plans. Now, the next thing that we'll look at in some of those plans, and I've got a few resources for you as well, and you'll do some practices too of just drawing them out yourself, are hatches. So hatches are different patterns that signify and represent different materials in a building. So a building itself is a composite exercise of adding in lots of different materials to make the building itself. It's not just made out of one giant piece of marble that we've chipped away at, like I've been kind of describing some of these 3D style drawings to you. I say, I'm imagining it's a piece of marble and I'm chipping away at it. A building, it's made out of pieces of wood, brick, metal, glass. All of these insulation, all of these different materials are coming together to make the one piece of to make the building itself. So we need to, in our drawings, show those different materials so that way we can understand how it's getting constructed. Because as I mentioned on the very first day of classes, the set of plans, the construction document, is the legally binding contract of what this building is going to be. So everything needs to be specified of what it's being made out of. And one of the ways we can use shorthand to understand these materials is through the different hatch patterns that we are put in there. Now, how materials are represented on hatches can often vary based on whether it's in a section. And so a section is if we cut the building open and are looking at it from, half of it from the inside, or if it's an elevation, if we're looking at it head on from the front, back, or right or left. When you're adding in hatch patterns, you don't necessarily have to cover the entire area if it's very large, particularly in an elevation. So you can just put little bits of pattern in there. But typically in a section, we are going to cover full areas with the different patterns. So looking right here at this detail section, so it's super zoomed in. We can even see here that it's done at a pretty large scale. And at the end of this lecture today, we're going to look at scale and try to understand it a little bit too. But so this is very zoomed in, so we can get a lot of detail. And there are several different patterns designating the different materials. As you look at more drawings and as you get more familiar with these hatches, you are going to be able to look at them and immediately identify that this is, finished wood, and this is gypsum wallboard. This is a 2x4 of dimensional lumber. This is rigid insulation. This is fidget wood on this side. You're going to be able to just immediately see those patterns and identify them. But even then, while you're looking at drawings, they're going to have little leaders or notes pointing to those materials, specifying what it is again. So that's just going to help verify that it is the material that you are looking for or want. Now, linked right here is just a little cheat sheet PDF document to just kind of give you, here are very common materials used in drawings, and here how they are designated with hatch patterns. Now, we're going to see these in different areas of drawings and in different parts of the building when it's constructed. So earth, the hatch pattern for just earth or dirt, we see that a lot in section views, particularly towards the foundation, because the foundation itself is seated in the earth. Gravel is something that we see a lot in our foundation plan as well, whether it's being compacted against like a slab on grade style floor, or it's helping line around our French drain to prevent dirt from clogging any of the holes in that pipe. Sand, again, is used a lot too in our foundation plans. We'll see sand around there. Concrete, we'll see used quite a lot of places. So this is then would represent cast in place concrete. And we can see here that there's two different designations for concrete. So there's concrete and then concrete in elevation. So this would be then concrete in a section. And it's a series of those triangles and little dots. And that actually is to represent the aggregate and sand and cement that makes up concrete. So there's a kind of a little bit of a reasoning behind why it looks like that. Some of them, it's pretty straightforward why they look the way they do. So for example, gravel, it's pretty obvious why gravel looks the way gravel does. And you might even be looking at these two and say that concrete in elevation looks a lot similar to sand. This just seems like the dots are more compacted or closer together. And what you'll come to find when we start on the computer portion of the course is that these are actually the same pattern in the software. It's just one of them we just scale to make it so it's more spaced out. But they'll have two very different signifiers in a drawing, and that's again why we would want to put leaders or annotations next to our material just to reiterate what it is and what it isn't. But we'll see concrete in all different portions of our drawing. We could see in our foundation, absolutely, but we can also see it in our floors. If it's a commercial building, we'll see it in our walls, potentially even could be in parts of our roof system, depending on what we're making. Same thing with steel and aluminum. You can pretty much find those anywhere in your drawing as well. Aluminum is used a lot for flashing around the different connections between the foundation to the floor to the walls to the roof, and then any openings in between. We'll often use aluminum to help make flashing to keep those connections nice and tight. A CMU, or a concrete masonry unit. Again, this can be seen in the foundation and the walls. You could see it in a floor. It's probably not going to be incredibly likely. And the same thing with a roof. And then this again is going to have a different pattern to it based on whether you're seeing it in section versus whether you're seeing it in elevation. So when you're seeing it cut open, it doesn't really look like anything that is a CMU, but when you're seeing it in elevation, it looks exactly like those big CMU bricks look. So it's almost as if you were just looking at it head on. Then just a standard mason brick. So again, in elevation, it looks just like you would see it head on. And then in section, it's just a series of these diagonal lines. And for those of you who have any kind of engineering background or 3D modeling background with like Inventor or Fusion, or took any drafting courses in high school, this is a very standard section for pattern for, if you don't know what the material is, you would just kind of fill it in with that 45-degree line. But in architecture, it means brick. And brick, you won't see a lot of foundations nowadays. If you were looking at older houses, brick foundations exist. Now, not too much. I haven't seen any houses built in the last, 30, 40 years with brick foundations, but that doesn't mean they can't exist. But walls especially, you're going to see bricks. You might see exposed bricks for floors. Wood framing, so this is going to then signify dimensional lumber in your house. And this again is going to appear in all different sections of your house. It's going to be in the foundation, it's going to be in the floor, it's going to be in the walls, it's going to be in the roof, particularly with residential. Now, wood blocking in a section is going to typically show things like maybe trim going around a window or a frame for a door, and it's just the one signal line versus the two. Wood sheathing, so that's going to be again seen a lot in your floors and your walls and your roof, because this is going to be that layer sitting in between your frame and then your finish. And then wood finish, again, you'll see this in your floors and your walls. And depending on the type of roof you're using, I guess you could see it in your roof as well. And then we've got two different types of insulation, and they're shown differently in our drawings. So batt insulation, the pink fluffy cotton candy in the walls, is shown with these wonderful squiggly lines, and it's always one of my favorites to watch students draw these in. But you'll find this in your floors and your walls and your roof. Rigid insulation then is the foam boards, so oftentimes we'll also refer to them just as blue boards. We're seeing this much more commonly now, particularly in buildings where like sustainability and energy efficiency is becoming more prominent and an important part of that particular building. You'll have rigid insulation just because it'll be a higher R value and less for your heating and cooling bill. Um, One thing to keep in mind is that the CMU and the rigid insulation, the patterns again look very similar, just like with the concrete and the sand. And that's because, again, this is technically the same pattern. You could absolutely use the same pattern to do it, and then just one of them you've rotated onto an angle. So just keep that in mind when adding them into your drawings. And we're even going to see in the set of plans I have that technically they did, in my opinion, the rigid insulation incorrectly. But that's why some of this stuff is just me giving ideas and giving you guys, hey, this is the standard and this is what is expected, but some of it you can go off my recommendations a little bit, but I would recommend just do what I'm telling you. Gypsum wallboard or drywall, and again, if I just zoom out, we can see gypsum wallboard and sand look super similar, and you're sure right, they are, because it is again the same pattern, but they're just designating two different things, and that's when those leaders come in handy. And we've got a couple of other different patterns going on as well. So you can find all of this stuff online too if you just Google search, hatch pattern wood finish, and you'll find different examples of it. And that is what then you can choose to go with in yours as well. So if we look at the sets of plans that are up on As You Learn, we can see a couple of different these patterns in action in this elevation. So with this house, part of the foundation, since it's built on this slope, a lot of the foundation is exposed. And so this is then that poured cast in place concrete, but it's just exposed here on this part. And then we just have vertical wood siding. And it's going to look in this plan just like it does in real life. If these were vertical wood panels, it looks just like that. And then we've got our hatch pattern for our concrete or cast in place concrete there. Here we have a section cut of the house. So this is if the house was cut open and we were looking at some of those construction details. And this is where we can see some more of those patterns come into play. So we've got that squiggly line here for the batt insulation. But even then, if you're not 100% sure that that's what it is, it has this little leader with this annotation to it that says this is batt insulation. It's 6 inches thick and it has an R value of 19. We have some more hatch patterns too in play, and see they, for their sheathing here, just use this diagonal line, which I wouldn't recommend because that would be brick, but it still is able to be used because we then can look at the arrow and say that this is OBS sheathing. And then here we've got this rigid insulation, and how I mentioned I would prefer it as a vertical grid, a vertical horizontal grid, not this diagonal one, because then that could be inferred as a CMU. And that would just be my personal opinion, personal preference, but then we see that it has an R value of 13, rigid insulation. We've got a bed of gravel underneath this concrete. And then the concrete, the cast in place concrete, is shown with the series of triangles and dots. And then we even have some gravel here just shown a little bit differently for the French drain that is going around the entire house. And we can even see in here some different line types happening. So this would be our rebar tying the foundation wall into the footing shown. We've then got rebar for the concrete slab that's in here. And we've got our pattern for our just filled earth going around the building. And then here's a different section corner detail with, again, lots of different hatch patterns with the different materials to signify what is happening in there. And to look then at this condo again, we've got some hatch patterns to show brick, veneer, and then the horizontal siding that is on the building, and the composite shingles that are also on here. And this is what I meant by not having to fill the area in with all of the hatch patterns. So they left areas blank intentionally, so that way they could also put these annotations, these leaders in to help signify and just describe the different parts, because otherwise you were not going to be able to put the text that says brick veneer without being able to read the whole thing. And then again, we have some hatch patterns to show different materials that are being shown. Hatch patterns are really prevalent in these section views, in these cut openings of the building. So we've got different hatches for like the dimensional lumber. So this would be my sill plate for my wall. And then we've got our header for this window opening here, and our double top plate, all of that dimensional lumber shown with those crosses through it. And then some different patterns for our cast in place concrete, for our earth fill around it, for our gravel, our bat insulation. This plan was done using CAD, so that's why these lines are much nicer than the other plan we were looking at, where it was pretty obvious that that bat insulation was at least added in manually, but that's okay. And again, we can see lots of different line types. We've got our dashed lines, we've got hidden lines, we've got solid lines happening. We have here in our roof framing plan, which we didn't look at before, but again, we've got these center lines, which are representing the center of each joist, or rafter, excuse me, going across the roof, and then a center line to represent the ridge as it goes across the building itself. So all of these different patterns are just going to be visible and in our different plans. And the more you look at these plans, the more familiar you get with the patterns. And if you're ever unsure of one of them, you can always just look on the internet and find out. Or you can email me and I'll tell you. But sometimes the internet might give you a faster answer. Symbols for different doors and windows in plans and elevations. Again, they're going to look different. In elevations, a lot of our doors look exactly how they appear just in real life, and you'll even see it with, if it's a panel style door, you'll see those 6 different panels in there. Or if it was, an exterior door that has a window or a big glass pane, that would be visible in elevation when you're just viewing it head on. In plans, we can see these doors a little bit differently, but they're still going to symbolize just how that door functions. So the typical door is just a single swing or a single flush door, in which it's symbolized by the door itself, and we would see which side of the wall it's hinged on, and then which way it swings open. And you could show it the way this one's shown, where it's just a little bit open. Typically it'll be all the way, and then it'll have the full swing, or you can even have it open all the way and just a 45-degree line. And that just kind of helps understand the traffic patterns, the movement through the house a little bit better if it's all the way open, to make sure that you don't have anything else in the way of it. But that would just be a single flush door. Sliding doors are shown as 2 doors that would slide, so we can just see kind of the 2-door panels. Accordion doors, bifold doors, and so we're just kind of seeing which way they open, just so we can understand it a bit more. I don't have on here a pocket door, but a pocket door is, and let me see if I've got that little pen feature available in my thing. Boop. I'll draw it really crudely for you. So if this is my wall, my pocket door would show kind of the piece in my wall that it sits in, and then the door partially kind of like sticking out, and then this of course would be empty right in those areas. I know that's a pretty crude drawing, but it would look just like a door that sits inside the wall and can slide in and out. Now on our plan, these are just going to be tagged, and we can look at that here in the, we'll look at the condo first. So we've got our doors, and they're just tagged with a little number signifier. And so this right here is door number 1, and this then is, where's door 2? I go just straight to door 3. Door 2 might not exist in this particular one. No, I don't see any door 2, unless door 2 is this cased opening here. Ah, interesting. But like we've got door type 6, door type 3. Door type 3 is used again here as well as here. This is door type 8. And so I can tell a little bit about the door type with just the symbol. So I can tell that this is a single swing door and that it is hinged on this side and opens in that direction. I can tell this is a sliding door. I could tell this is a bifold door. So I can get some information about the different types of doors, but each of them are just numbered with a specific door type. Oh, here's door type 2. It's this little bifold door for, I guess this is a pantry. But I don't really get any other information about the door on the plan, just because that's really going to busy up the plan, and there already is a lot of information on these plans. And so instead, I'll find that information on another sheet that's called the schedule. And here, so since this just has 2 sheets, I've got my door schedule right here. And so it says that door, if it's tagged door number 1, it is in the entry area, and that it is 3 feet 0 inches by 6 foot 8 inches. It is 1 inch and 3/4 thick. It's made out of, my guess is that HM would be, I don't even know, really. My guess, since it's the entry, it's probably a metal door. And then it's got door type A, which we then can figure out from somewhere else what type A is. I'm sure there's going to be some other document that would tell us about it. That it's got glass insulation on it. Any other just kind of other pieces of information, we would find all of that in the door schedule. Same thing then with like window types, is they would be tagged with just a signifier rather than put all of that information here in the plans. And we'll just see like the different types again here in the lake house, and we'll just scroll up to some of the plans. So here in the lake house, we've got this door here. So this one, we have a little bit of a different numbering system, but it's still the same thing of just a symbol to show the door. And then this is door 101. This is door 104. This is 105. We don't really have too many different types. We've got some bifold doors here for 107. So my guess is that is just signifying either A, just to help signify the rooms a bit better on the schedule, or these are genuinely all different sizes. I can't imagine every one of these doors being a different size, but I don't know. I did not make these plans, full disclosure. But we've got just a lot of single swing doors, and then we appear to just have this one set of bifold doors. Now, there are on these plans some things that look like sliding doors. So right here, this looks like it's a sliding door, but I can tell it's not because of this particular tag here. And I'm getting a little ahead of myself, but because this is a hexagon versus this being a circle, and the same thing here, it's a hexagon instead of a circle. And so that actually tells me that this is a window. So again, that's where some of these different symbols and just knowing what the different ones are come in handy. Now, since this is a little bit more of a complicated structure compared to that 2-apartment condo, we've got more sheets. but I still would have a sheet that has a schedule for the windows and then a schedule for the doors. So I could go into my different plans and I could see that here are all my doors, and I could find out, okay, door 104 is 2 foot 6 inches by 6 foot 8. This is how thick it is. It's a wood door with, it's type C, which somewhere in these plans it's going to tell me what a type C is, but I don't want to search too hard and waste all of your time. But okay, here, boom, type C. So here's our doors: type B, type A, type B, type C, and type D. So if it's a type B, it's just a single flush, very plain door, but it has an insulated core. Type C is just a hollow birch style door. So we just have our kind of different door types signified here. Thankfully, we didn't have to search too hard for it. Personally, I would try to fit the schedule with those door types on it, but that's okay. And then kind of any other information about the door that I might need to know regarding it. And all of that can be found again here in the schedules. But if we look at these doors in our elevation style, which let's find the side that shows us our front door. Which do we not have the one that shows us our front door? So it would be, well, the garage actually is blocking it, unfortunately, so we can't even see the one door that's on the outside. So we'll just look at it on the condos then. We have our doors here, and they look just as they would appear if we were looking at them in reality. The way they've also kind of tagged their door here is just a little bit different than the lake house one did, where they did this 3/0, which could be interpreted as 3 foot 0 inches, 6 foot 8 inches. Sometimes what I'll do in tags, and I'll bring up my ugly pen again, is I'll do like 3, 0, 6, 8. So I'll just write like, and it just kind of seems like I wrote 3068, but it can be interpreted as 3 foot 0 inches, 6 foot 8 inches. I'll just actually move that there since I'm using it more often than I thought I would. So you can write it that way. You could do it the way I did. The preferred method would be to do it the way this schedule shows, things like that, where it's the 6 with the foot mark, a dash, and then even if it is 0 inches, you are putting a 0-inch marker in there. And so that's just a little bit about doors and how they are going to show up. Now, of course, too, if you're ever unsure about it, about what style door to put, you can always just search for it online, look at the AIA Student Handbook reference, or just ask me and I will be happy to tell you. It's what you pay me for. Different style windows. So these are going to appear differently on the elevation and the plan again. When I do hand draw plans, since I'm never doing hand draw plans to finish everything off, I just always kind of show my hand drawn plans as if it was a fixed window, and we'll see that on the next slide. But what they kind of look like in plans is if you had sliced the window in half, and you can see some information a little bit about like the framing, and then in this case you've got 2 panes of glass that would slide up and down against each other, 2 panes of glass that would slide across each other. And so we've got our double hung. Also in elevation, we'll sometimes have double hung windows that will have like arrows like that to let you know that it can move up and down as well. That's something I've seen in elevations before. The awning style window has this little line, hidden line here to let you know that it's hinged on this side and that it opens up then in that direction. Which, to backtrack a bit, with doors too, what I've sometimes seen for doors in elevation And software like Revit will do this automatically. Is like if this is my door in elevation, it will have hidden lines to let me know that it's hinged on this side. But in the elevation, I don't necessarily would know if it opens in or out. I would just know that from the elevation that it's hinged on that side of it. But that's just what these little hidden lines here are referring to. A casement style window, again, it's just letting us know which side the window is hinged on. And then in plan, it's just letting us know that it opens outward versus a hopper window being hinged at the bottom and opening in to a building. This is some French word I'm not even going to try to pronounce because I'm going to embarrass myself. But it's kind of just like a little bit of some gaps. You'll see these a lot in like Florida and kind of southern areas where they kind of will open sort of like blinds almost, but it just opens up the window to help ventilate areas. Or then a fixed window, which is a window that just doesn't open at all, but it's there to just let in natural light. And so when I do hand drawings, I'll usually just show windows like this because it's just, to me, a little placeholder for a potential window that I'm going to add into a set of plans. So to look at those again here in sets of drawings. So we've got our windows in elevation. And I know all of these are windows because of the hexagons. So that is a window tag that signifies these are windows. And then I can see that this is a sliding window, or rather I'm inferring from the fact, that I looked at the floor plans and saw they were sliding because it doesn't actually have those little arrows. So I'd have to just verify from the plans and then the window schedule as well that these are sliding, because technically these could be fixed or casement. These right here would then be awning style since they have that to let me know they're hinged up here. And then again, if we look at it in plan, I can see that this is a sliding window because of the symbol sliding, sliding, sliding. All around this house, it uses just sliding windows, except for up here in the loft area. It has those three hopper or awning windows, And so these are then just tagged with saying this is window type A, this one's C, this one's C. I've got two G's here, two E's. And so then that tells me to go look at the window schedule, and I get information that window size A is 3 foot by 3 foot, window size B is 3 foot by 3 foot, but it is a different type of glass. Window type H is 6 foot by 8 foot, so I'm getting just kind of different pieces of information about each of these and kind of what they do and what their function is. So we would just always look at it in plan to help get the first gist of it, confirm it then in the elevation, and then confirm it in the schedule. And that's why with a set of plans, none of these alone are ever going to tell the full story of the building. We have to have multiple drawings to understand it because buildings are complicated structures. Next are all of those different reference marks that you've been seeing in like the floor plans and the elevations and wondering, hopefully you've been looking at some of them and wondering what the heck those are. And so these are things like those tags for the doors and windows, but there's also ones that are then helping us understand the link between the floor plans to the elevation or the sections to where in the building it's cutting open. In these different signifiers, and they can be shown in several different styles, but the traditional way is to kind of just show it with this circle and like arrows pointing to it depending on what it is. It's letting us know the view number and the sheet number. And in the next lecture, we're going to go over sheet identifiers pretty heavily. But again, this is something that based on firm to firm, they're going to have some slightly different numbering systems for things, and that's okay. But it's going to tell us the view number and the sheet number we can find a particular view in. So these right here would be elevation markers. We would see them in floor plans, and it's telling me that if I go to view 1 on sheet A 2.1, I would see the elevation of that side of the building. So if I had my floor plan here, which, oh my goodness. So if this was my floor plan, and this was my elevation marker, would say that I would see this south facade of the building if this was north up here. It would say, go look at view 1 on sheet A201, and you'll see that south side. And then if I had another one over here, and then we'll just say inside of it, it says, 2 on A201. That then says if I go look at view 2 on sheet A201, I would see the north facade of the building. And so you'll see these around the perimeter of the outside, and they're just representing exterior elevations. You'll also see some signifiers for interior elevations, which would still just be telling you the view number and the sheet number to go look at. And then these here are section cuts or section markers, which again is saying to go look at this view on this sheet, and you'd see the vertical section cut of the building. So these style markers you're only going to see in plans, because in the floor plan it's just telling us which elevation to go look at. A section marker, though, you're going to see in elevations and floor plans, and potentially even other section views as well. A north arrow always exists in plan views, so our site plan, our foundation plan, our floor plans will always have an arrow to let us know which way is north, but again, those are only going to exist in plans. This right here is what is called a revision cloud, so it would go around a different area to just say like, hey, go look at this particular detail for a change that's being made. And linked right here in the presentation just brings you to a good website that has lots of different symbols and just kind of what they mean, and just references for what that is just referring to. And also on this website, they do have here in, I believe this one, yeah, they've got a lot of the hatch patterns too, and things that you might see in electrical plans. So this is a great website, arctoolbox.com, for you to find some of the stuff that you may be looking for. So to look at some of these things again in our sets of plans, just because I think it's better for us to kind of reference it here. This set of plans does not do the best job of tagging the different plans themselves. And I think that's particularly just since it's only these two drawings. Like there are, oh no, I made my mouse move crazy fast. Hold on. Like I can understand these elevations in relation to this building without having elevation markers for it. So they didn't do a particularly good job, one that I think they did well for, with like the elevation tags. And the section itself is, since it's labeled here as a typical section, it's not necessarily going through any one portion of the building. They're just saying, you know what, typically here's how the construction of the building is going to be happening. So they're not actually bringing it through a specific part, but we can still see again those tags for things like doors and windows, and a couple other tags for like, or just generic symbols for things like the sink, the stovetop or the range, the refrigerator, the different symbols for like the toilet, the sink, the tub. All of that stuff can be shown pretty well in this particular plan. Now in our lake house, we see a lot of these different symbols happening. So if we're looking at our floor plan, we see lots of symbols for section views in particular. So right here, running through, and let me just make this so the whole sheet fits. Running through the lower level, we have this saying that here's a section cut, and that section cut can be found view 1 on sheet 4. And so here in my title block, this is telling me it's sheet 2. And it's saying if I go to sheet 4 and I look at view 1, I'm going to find a section cut that goes through the house here and looks at this side of the building. And that can even be seen still on my upper level here, because that cut's going to go through the entire building vertically. So we can even see it here then in this loft area. So if I go look at that sheet, I'll be able to see vertically the building cut open, looking at this area that faces like the dining room, the kitchen, this deck, the crawl space underneath it, a little bit of this bedroom. All of that stuff would be included, and the loft area above it. So I'm going to go to sheet 4, and I'm just going to scroll down, and here I am at sheet 4. And if I go to view number 1, so all of your views are always going to be labeled with a view title and a scale, as well as then just a signifier for the view. So they're always going to be numbered and labeled. Every view is always going to have this title on it. And then I can see here that building cut open, and I'm looking at the living room, a little bit of that bedroom, the loft, the utility area. So it's just kind of helping show how this is relating to this. So that's where that section marker comes in. So same thing then is here we've got view 2 on sheet 4 is then cutting through the building this way. And so if I go back to sheet 4 and I go to view 2, I can then see the building cut open in that direction, and it's just giving me some construction details. And even then, in this section view, we have some areas that are highlighted with this phantom line telling us to go look at view 3 on sheet 4, and then that gives me information about that wall in more detail. So since this is done at a scale of 1/4 inch equals a foot, this one's done then at 3/4 of an inch equals a foot. So it's just giving us zoomed in area of this wall to help give us some more information about that connection. And then even in this section view, so even in this zoomed in section, it's telling us to go look at view 1 on sheet 7 to get even more detail about this particular connection for how this loft area is played out. And so then if I go to sheet 7, so I'm just looking at my sheet identifier here, and I go to view 1, this is done at 1.5 inches is equal to a foot. So then this is even zoomed in even more, and I can get more detail about how it's put together. So we're always just looking in our drawings if we have anything that's kind of highlighted, or we see a circle with 2 numbers or 2 signifiers in it. That's just saying, hey, go look at this area and you'll find more information about this one particular thing happening in there. So in our elevations too, we can still see things like our section cuts or section markers and things like that. So we can still see here, you know, that this is a detail section. And if I go to view 2 on sheet 7, I can, sheet 7, view 2, it's a detail about that skylight, and it's done at 3 inches is equal to a foot. So every single view, no matter what, is always going to have a title, and it's going to tell me the scale, and it's going to have a number to it. And then anytime in drawings I see like a number scheme kind of like this, but maybe, you know, it says, you know, view 1, and then it says sheet A101 or things like that, it's going to then just be telling me to go find a view on another sheet for more information related to that particular view. In the kitchen area of this one too, we'll see, so we have this one right here, which is representing an interior elevation. So if you see symbols like this is saying here's an interior elevation, and to go look at view 7 on sheet 5. Sometimes it might be shown, and they had a good example on here, like this instead. And so this is saying go look at view 1 on sheet A401, and then in view 1, view A would be looking at this particular wall, because again, this is an interior elevation. So there's 4 walls here. View A would show you this one, view B would show you this one, so on and so on. Now, in this particular plan, they're not telling you which one of these walls. They're saying that it looks at this wall, it looks in this direction, and it looks in this direction. That's why these 3 are filled. But from going to sheet 5, which let me zoom out, I'm on sheet 4, never mind. I can infer which one of these is which one by just looking at things like where the cooktop is versus where the sink is and where the refrigerator is. But then this is giving me information about like the cabinetry layout and how tall the countertops are, and just different pieces of other info related to like these cabinets that I wouldn't get from a floor plan, and I can't get from necessarily a section view depending on where that section is cut. And so I can get information like that from interior elevations, like these kitchen ones, and then I can even confirm that these are the kitchen elevations and what scale they're done at. So again, these are a little larger to help show some more detail. Typically, a lot of your views are going to be linked to a scale. And again, I'll hit on this in the next lecture, but things like our floor plans and our elevation, and then our full building section, those are always going to be done at the same scale. So since the floor plan was done at 1/4 inch equals a foot, the elevations are done at 1/4 inch equals a foot, the full building sections are done at 1/4 inch equals a foot. And that just helps us tie and understand how this relates to this a bit more. And even so, the foundation plan's done at the same scale. Things like the site plan and then those detail sections, those can be done at different scales, because if I did this site plan at the same size, it's not going to fit on the sheet of paper. So those then are going to vary in scale. But our floor plan, our elevations, and our sections are all going to be tied in the same one. Okay. Second to last thing I'm going to cover today is architectural lettering. And so architectural lettering is how we write things on drawings. On the computer, it's pretty easy because all we do is hit caps lock and then we just pretend we're screaming all the time. Handwriting can be a little bit more difficult, particularly because over the past 10 or so years, really has not been pushed a lot in, elementary school and middle school and things like that. But handwriting is really important in the field of architecture, and it sort of is, at least in my opinion, like you are judged a bit on your lettering style and how neat it is and how much effort or time you've put into it. Originally, it was a standard for clarity because we could tell the difference between all caps easier than lowercase. So things like an A and an O couldn't be misconstrued from each other. And now it's just a tradition that we keep going on. A good way to get nice lettering is to stop writing lowercase letters ever. I very, very, very rarely will write in a lowercase letter, and when I do, it feels really awkward. Everything I write, whether it's, a check to my landlord or my grocery list or a note for a kid to go to the nurse, everything I write in lettering, in all caps. And so if you looked at your feedback files, it looked like I was screaming at you. I wasn't screaming, I was just lettering. And then when you're starting out to practice your lettering is to use guidelines. So on the worksheet you have for today's lecture, there are guidelines provided for you for lettering, but that way you can just try to help keep it at a uniform height or consistency as you letter it. And I would recommend first, before you try to really develop a style, though there are plenty of styles out there that you can emulate, and that's another thing I'm going to encourage you to do, is if you have horrendous handwriting, to first focus on just improving your uppercase handwriting in general, and then you can start going for a style choice. Because if I can't read it, trying to then give it like a little bit of a pizzazz is not going to help. Now, when trying to develop a style or even just to improve your architectural lettering, you can find so many wonderful examples on the internet to try to emulate. And even just installed on most computers are two different text types. There's City Blueprint and Country Blueprint, which are two different architectural lettering styles that just kind of exist already. What I have linked here is just a YouTube video from How to Architect, where he goes over how he letters and how he draws every single one of them out, even using tools like a T-square to do so. What I have linked right here is a font that I decided I really liked, and I chose to mock or model my style of lettering after this font. And then there are some choices that I just liked how they did it, and I really went with it. So things like this little hat, I would kind of call it a tail, but I guess it's a hat on like the B or the D. I always do that when I write my B's and my D's. Whenever I write the letter E, I always have the middle line a little bit longer. This extra tail on like the F and the P and the R. My P and my R typically are also very similar, and so in class I'll give you a little demo of it. I just don't have a camera here for this recording. But I just kind of found this font and I really liked it. And at the time too, it was available for free, which was wonderful. And so I downloaded it and I just tried to emulate it as best as I could. And then even on the computer on occasion, I will use this as just a font in drawings itself. And so this font actually came from this website here, Creative Market. And one thing I love about Creative Market, and this is just a slight side tangent for you, is that they have lots of different stuff available to put into different presentation files to really make your drawings or your mock-ups all that much nicer or better. Now, things on here do cost money, which we all know is gross because I don't have $49 to spend on this super duper bundle of food illustrations. But what they do have available, and I'll just sign into my account real quick. So you have to make an account with them to do this. It's free of charge to make an account. But what they do have available is here in this Get Inspired tab, they have, they have free goods. And every single week, they put 6 new items available here for free. And I'm able to download this PowerPoint, this font, these clip arts of unicorns, this font, this Lightroom preset. I've never used Lightroom, but I'll download it. This interior with a blank wall and armchair. Maybe I want to use that in something one day as like a mock-up. I'm able to download all of those, and I don't even have to keep them installed on my computer because here it's going to keep track of them in my purchases. So here in my purchases, here in my garage, I have then everything I've ever downloaded from them. And after this week is up and this interior with blank wall is no longer free, I'm still going to have access to it forever. So I use this a lot just for finding fonts. You never know what you're going to use in the future, and just to be able to have this 44 pages of just different fonts and different vectors and things to put in my mock-ups and my drawings is, to me, wonderful because it then is going to make all of my stuff stand out from the very boring typical Google slide, and it's going to make it look like I put so much more of a high effort in it, when in reality I just downloaded these for free. And so rather than trying to find, a picture without a big ugly watermark on it, I just now have this picture of this chair with this little thing, and then maybe I could put my little interior design of like some framework thing based on it. Depending on what assignment I have, maybe I'll never use this picture ever, ever, ever in my life, but I don't know, I have it now. Is that a hoarding mentality? Pretty much, but I'm just hoarding things digitally, which isn't as harmful as filling my house with garbage. So maybe this is interesting to you. Maybe you're just like, ooh, that's cool. I can use these in presentations to make them a little bit more engaging for my audience. Maybe you're just like, is she going to shut up yet? And the answer is yes, I will shut up soon. So that's how I got good at my lettering. Was I found a font I just went looking online, and then I found one here on Creative Market, and I just emulated mine based off of it. And I'll show you some examples in class of me practicing my lettering, but you can see it on your feedback files. I have lettering, and then anything I ever write, I just always letter it. Last thing for today, and we'll touch on this more in depth next lecture when we look at our reading and understanding construction drawings, is scale. And so one of the things was optional for you to get for this course is an architect scale. So I just kind of want to go over how an architect scale works. So on an architect scale, as you spin it around in your hands, there are 4 different potential scales you could use. So we've got a 1/2 inch, a 1 scale, a 1/4, and an 1/8. And the 2 scales are running in opposite directions. So this 1 scale is running left to right. This 1/2 scale is running right to left. This 1/4 one is running this way. This 1/8 is running this way. This number here is signifying how many inches on paper is equal to 1 foot in real life. So it's saying here a 1/4 inch on paper is 1 foot in real life. And that means then from here to here is a 1/4 inch on paper. From here to here is 2/4 of an inch or 1/2 of an inch. From here to here is just 1 inch on paper in, if I had a piece of paper in front of me. And the same thing then here is this is just a marker from 1 inch to 2 inch to 3 inch. Since this scale is 1 inch is equal to a foot, it's just pretty much saying that every inch on paper is the equivalent of 1 foot in real life. Because when we're putting those drawings on paper, we're shrinking them down so that they can fit. So the large tick marks, as I just mentioned, running across are the feet. And then next to the scale identifier are going to be inch marks. Depending on the scale, so the smaller this fraction is, the less marks that they're going to be. So since this is a 1/4 inch equals a foot, if you want to pause and count, you can see that there are 12 markers total there. So each one of these little lines on the scale is 1 inch in the scale a 1/4 inch equals a foot. Since this is a bit of a larger scale where we can fit more detail in, so think back to those detailed sections where they were zoomed in more, we have even more markers. So this is 1 inch, 2 inch, 3, 4, 5, 6, 7, 8, 9, all the way up to 12. But while I have 1, I also have 1/2 an inch, and I can even get detail up to like a 1/4 of an inch because this scale is zoomed in so I can get more detail in it since it's larger. No matter what though, the scale will always kind of help designate where 3 inch, where 6, and where 9 is, just to help figure out like a length a little bit easier. Now, as I mentioned before, the scales are always matched with their 1/2 equivalent, and that's just to make it a little less busy with the numbers. So I've got my 1/8 of an inch equals a foot scale running in this direction. and I've got my 1/4 inch equals a foot running in this direction. So these lower numbers are associated with the 1/4 inch. So this is 0 feet, 2 feet, 4 feet, 6 feet, 8 feet. Every number isn't labeled, but then I can infer this number in between. This would be 1, 2, 3, 4, 5, 6, so on and so on. The reason they're paired with their half is because these smaller, higher up numbers are paired with the 1/8. And so this is 0, 4, 8, 12. But I then can actually borrow some of the line work to help fill in some of those blanks. So this would be 1 foot, 2 foot, 3 foot, 4 foot, 5, 6, 7, 8. And then the same thing with, my 1/2 inch scale is if this is 0 feet, this would be 1, 2, 3, 4, 5, 6, 7. It just happens to actually end on the 7. So don't just take that as always it's going to be that way. And then the same thing, with these other ones. So that's why they're always paired with their half equivalent. Aside from this 16, this is just a regular old ruler running across. We could also infer it as this is a 1/16 of an inch equals a foot if we were using a scale that small. So then this would be 1, 2, 3, 4. This would be 16 feet, 32 feet. So there are no signifiers for that, but we could use this for a 1/16 of an inch equals a foot if we wanted. So how would we use an architect scale if we are reading it off a drawing? Typically we wouldn't. Typically we would refer to the dimensions, and we'll look at those dimension schemes and stuff again in the next lecture. I don't want to make this one too heavy because I feel like I've talked quite a bit already. But to read a line, we would align the 0 of the scale with the line, and we would note the closest foot mark it completely passes on the other end. And then we would slide our scale over so that line is sitting on the foot mark, and then we would be able to read how many inches they were. So if I had this line here, and I was doing it at 1 inch is equal to a foot, I would note the closest foot mark I completely pass, which in this case would be 2 feet. So I know this line starts with 2 feet, and then I would slide my ruler over so that 2 foot is now sitting at the end of the line, and I would see how many inches I had left. And so this line at a scale of 1 inch equals a foot is 2 feet, 3 inches long. If I was using a scale to draw the line, what I would do typically is if I needed to draw a line that was 2 foot 3, instead of starting my line at 2 feet, I would just start my line at the 3 inch mark and just draw up into the 2. However, another tidbit is we very rarely would ever want to use our architect scale to actually draw any line work. We instead just use it to kind of mark off where a line starts and where a line ends, and then we would use something like a straight edge, a triangle, a parallel slide, a ruler, just something else to actually draw our line work in, just so we don't muddle that edge up with like pencil marks or chips and things like that. And so again, with a 1/4 inch equals a foot scale, that is the one that we typically use very often. Typically very often, that pretty much means the same thing in a set of plans. So I just want to make sure that you are familiar with it, and that this right here would be just a 1/4 of an inch on paper, but it would be 1 foot if we were then to scale the drawing back up to reality. And it's another reason why I recommended you get a 1/4 inch grid graph paper, because if you didn't want to get a scale, or if this little dipping our toes into scale is a little confusing to you, you then can just use the graph paper as a way of just kind of measuring out the different parts or pieces, or rather the feet marks of your drawing. And so this would be 1 foot, 2 foot, 3, 4. We could even interpret it too as this is half a foot, 1 foot, 1 foot 6 inches, 2 foot, 2 foot 6 inches, 3, and so on and so on and so on. And with that, I am all done yapping for today. I feel like I talked quite a bit. Um, so to all of the stuff I mentioned today is referenced in here, as well as some chapters from the textbooks just taken out a little bit for you to um, look at, and then some other references for things like lettering. So just like some more information about lettering techniques and just different styles of it. Some information just about different symbols and what they typically look like. So last thing before I hit end for today is then you have a little worksheet to go along with today's lecture. If you are watching this in class, then I gave it to you at the beginning, and so you might have filled some of it along as we were going. But just to practice the different line types and the line weights that go with it, the different hatch patterns, the different symbols we see in drawings, and then again to practice some lettering. So please make sure you either scan or take pictures of your work and put it up on As You Learn. And if you have any questions, let me know, and I will catch you guys in the next one. Oh geez, I talked forever. Look at that.